Hi, this is Lou with MeterBuilder. The point of this video is to show you the procedure for calibrating your own couplers and to see how well we can get an inexpensive coupler to perform with MB-1. MeterBuilder has a unique feature that allows you to calibrate almost any broom type coupler using MB-1's coupler calibration algorithm. If you already have an MB-1 and also already have VHF and UHF couplers, you probably can interface them to MB-1, save yourself some money, and achieve a level of accuracy that's limited only by the reference meter you use for the calibration. You may have seen the pages on the MeterBuilder website that show how to interface to birdline sections. We included the section on birdline sections since many users already have a collection of bird slugs that cover a variety of power and frequency ranges. Today we'll go to the other extreme. We'll calibrate the coupler section of an inexpensive Radio Shack meter, something you can pick up at Hamfest for about $3. You've probably seen this particular configuration. It's got the normal configuration of two SO239 connectors, and you can see here what I've done is I've wired a dual RCA connector, and this is wired directly to the coupler. The coupler has been disconnected internally from the meter, and so this is connected directly to the forward and reflected coupler port, and this is what I'm going to plug into the back of the MB-1. Okay, so again, the intent is to take an inexpensive coupler and see how good a job we can do with MB-1's custom calibration. The first thing we have to do is pick one of MB-1's 4 coupler ports to use with this coupler. There are already 3 couplers connected to MB-1, so we'll choose coupler 4 for this exercise. Now these are the RCA cables that are coming out of the Radio Shack coupler. We simply have to plug these RCA cables into the appropriate forward and reflected coupler jacks in the rear of MB-1. So let me go ahead and do that. The approach that we've discussed with menus also applies to setup operations. Namely, I have to first select the menu for the type of operation I'm interested in. In this case, I want to calibrate a coupler. So the first operation is to select the coupler menu, and I can do that by hitting the coupler shortcut button on the bottom section of switches. To enter setup mode, I apply a long push to the setup button. This is similar to the panel meter calibration we showed in an earlier video. This function serves 2 purposes depending upon how long it's pushed, and you can see that the silkscreen legends guide you through what the operations are. So let me go ahead and make a long push on the setup button. Okay, so I'm now in the setup menu for calibrating couplers. As you'll see, there are prompts and instructions on each of the LCD screens to guide you through the procedure. The first thing I have to do in this screen is to select the coupler port that we're calibrating. Now you have to use caution here. You don't want to erase or overwrite the wrong coupler. You can use the up or down button to select coupler 1 through 4. Again, coupler 4 was selected, so we were all set up, but the important point is to make sure that the coupler you're interested in either editing or doing a new coupler operation on is indeed the correct coupler. So now that we have the coupler number selected, we use the same paradigm we did with the menus on the bottom line. Let me go ahead and pick button 1, 2, 3, the third menu button, 1, 2, 3. So I've gone ahead and I've selected coupler 4. This screen is telling me that coupler 4 is previously set up. Do I want to erase the old settings? Now there are 2 options here. If I calibrated this and just wanted to do an edit, I would say no, but in this case we want to do a brand new calibration from start. So let me go ahead and erase the settings using the first menu button, option 1. We're now being prompted for the type of device we're calibrating. The choices are power coupler, RF current sensor, and generic. We're calibrating a power coupler in this case, so we'll pick option 1, corresponding to menu button 1. The meter is now prompting us to set the forward trim pot. With 15 bits of resolution, the analog to digital chain has a maximum output of approximately 32,768. We don't want to overdrive the front end system, so what we're prompted to do here is to apply the full scale power that we're interested in calibrating the coupler at, and then adjusting the trim pot to ensure that we're close to the maximum value without overdriving the analog to digital converter. We want to be as close to the maximum value to gain maximum resolution and accuracy, but we want to make sure that we don't top out. So that's the point. Basically what we're going to do now, we're going to make an attempt to calibrate this coupler at 500 watts. I believe it's only rated for 100 watts or 200 watts. I've got a couple of more, so if we blow it up we can repeat this with a more reasonable exercise. But let's go ahead and try 500 watts. What I'm going to do now is set up my reference meter. I'll be using an Alpha 4510 as my reference meter. Any accurate reference meter can be used for the custom calibration process. And I'll use that to determine when I'm applying 500 watts. This coupler is in tandem with the alpha, and at that point I know that my output power is at my maximum full scale value, and that's the point where I'll tweak the trim pot on the coupler forward port to a value of approximately 30,000. Okay, so let me go ahead and set that up so we can continue. Okay, here I have the alpha in series with the coupler I'm calibrating, and I set my output power to approximately 500 watts. It doesn't have to be perfectly accurate here. Maybe I can tweak it a little closer to the value we're looking for. Okay, so I've got my maximum full scale power applied on the through the coupler I'm calibrating. Now let me go ahead, and as this instructs me, let me hit any menu button. What I'm seeing here now, I'm seeing the forward and reflected ADC value. This is the value that's being read in by the ADC, and you can see as I reduce the power, the ADC value changes as well. But the point is, for maximum resolution and sensitivity, I want to get that number up to roughly 30,000. So without overstressing the coupler, let me power this down for a minute, and while transmitting 500 watts, I'll go to the side panel pot for coupler 4, the forward pot, and make an adjustment to get that number up to 30,000. Okay, this is a case where I am actually at the max value, and the maximum output that this coupler, in terms of voltage, that coupler was capable of creating was approximately 26,000. Not too bad, we can still get pretty good resolution with that, but you may find if the coupler that you're working with doesn't put out approximately 6.14 volts at full scale, you won't be able to drive this numeric that we were trying to set to 30,000 all the way to its maximum value. It just means that the coupler you're dealing with has a somewhat low sensitivity, but certainly this coupler is usable with MB-1. So in effect, we have the forward coupler pot adjusted, and we can continue. Okay, let me home in on the LCD, which is the important thing we're looking at. It's giving us the setup instructions. Being that we have the trim pot adjusted, it's telling us to hit any menu button to continue, and it's asking us whether the coupler that we're calibrating is an OEM coupler. Now, MB-1 has preset tables for some couplers that can be selected simply by selecting the OEM number of the coupler. But this is not one of those supported couplers, so we press no, which is option 2, menu button 2. This screen prompts us for the band we're using for main calibration. This has importance only if we're going to do band correction. For example, on the 10 meter or 6 meter band, if there's some roll off there compared to the reference band, we'll skip band correction in this demo, but we have to enter the value anyway. And since you may want to go back later and add band correction using the edit function, that number needs to be there. In this case, we're going to use the 80 meter band. If you wanted to use another band, you could go ahead and select it with the up-down switches, but 80 meters is fine for our choice. So to do the select, we pick option 1, 2, 3. Okay, so we've picked the 80 meter band. We're now asked to select the full scale power that we want to calibrate the coupler at. We decided we'd give this one a shot at 500 watts. The default is 2000, so let's use the down button to select 500 watts. Okay, and sometimes you overshoot or undershoot here, but you get the idea of what has to be done to get to the correct value. Alright, we're at our 500 watt full scale value, and again, to proceed we have to hit the select button, option 3. Okay, we're finally ready for the interesting part. We're ready to start calibration. You'll see that the software offers any of the 60 calibration points that MB-1 is capable of working at, or all points in the set determined by the full scale value that we specified, 500 watts. Now, the meter can be calibrated up to 30,000 watts, but once you tell it 500 watts is the full scale value you're calibrating it at, it'll stop offering you calibration points at 500 watts. Now, how many points do we need to do a good calibration? It depends on the coupler. If the coupler was ideal, only a single point would be needed, right? There's the power equals some constant times the voltage squared. But the whole point of MB-1's custom calibration scheme is that it deals with real-world couplers that are not ideal. If you're calibrating a coupler of unknown quality in terms of how closely it follows the ideal curve, start out with roughly 10 points, especially concentrating on the low power values, because that's where a lot of the couplers have a lot of difficulty. And after calibration, you can just run your calibrated meter against the reference that you use to calibrate it, and if it's in good shape, you're done. And if you see a couple of areas where the accuracy is not quite up to what your standards are, you can add additional points with the edit function. Now, before we frame the alpha to show calibration, what we're going to see here is that the meter is going to run us through each of the possible calibration points and ask us if we want to perform a calibration at that point. The lowest point where we can calibrate is 0.05 watts. If I wanted to skip that and move up to the next available calibration point, I'd hit the next. If I wanted to go back, I'd hit menu button 3. So 0.05 again is the lowest calibration point. We'll try to calibrate, and one of the things you're going to find is one of the difficulties is dialing in the exact value of the calibration. What you see here, and this is available by making use of the front panel pot. Okay, you can't see me turning that, but I'm turning the front panel pot up or down. And the nominal value is 0.05, but if the closest value I can set my transmitter to, as determined by the reference meter, for example, is 0.048 or 0.045, I'll dial that number in here before I go ahead and hit the save button to save that calibration. And what that's doing is it's It's performing a calculation by taking into account the actual power. It's assuming that I wanted to calibrate at 0.05. The actual power is 0.046 as example in this case. And the calibration constant that it will pop into the 0.05 watt calibration slot will be more accurate than if we hadn't provided this capability of specifying the actual power. So let's go ahead and try to do a calibration at 0.05 using the reference meter as a guide. Okay, let me go ahead and try to dial in 0.05 watts on the using the reference meter. Okay, and not exactly there, but I'm at 0.048, and this is a case where I would dial in. Don't know if you can see that. I framed out a little bit. I'm setting that number to 0.048, and I'm going to save that calibration value. Okay, it tells me that the next value that it wants me to calibrate is at 1 watt. I'm sorry, 0.1 watts. So let's see if I can dial in 0.1 watts. The RF controls on the on these rigs are pretty touchy, especially at the low powers, but that's pretty good. 0.099, and again I'll dial in 0.099 on line 4 of the LCD so that the calculation will be more accurate. Let me go ahead and hit the save. If I wanted to jump all the way up, let's say to 5 watts, okay, I crank the power up to 5 watts on my reference meter, as close as I can get it. And 5.012 as an example. The alpha number does jump around occasionally. Let's see if I can get that closer to 5. Okay, I have that reasonably close to 5.073. So let me dial in 5.073. Okay, the closest I have is 5.074. Let me go ahead and hit the save button. So you can see the procedure is basically walking through the different calibration points, setting up the power using your transmitter and a reference like the alpha or any other accurate reference that you happen to have, and saving the calibration points one at a time. Now what I'm going to do, I'm going to do a number of calibration points offline so that this doesn't get tedious. So I'll be back when I finished the majority of the calibration points. Okay, we're at the last calibration point, 500 watts. We'll try to dial this in as closely as possible. 498.8. Alright, that's the closest value. So we'll go ahead and do a save. After the last calibration point, the meter prompts you to press next. It's basically giving you the option, just in case we jumped ahead to the last calibration point by accident and missed the calibration point. So with this approach, you still have the option to back up to a previous point if you need to do that. If after the last calibration point we had simply proceeded to the next step, you would not have that option. So we don't need to do that here. We didn't mess anything up, so let me just go ahead next. It's asking me if I want to perform frequency compensation. I'll skip that step for this demo. It's not mandatory, and you can always go back later using the edit function to add band correction. So I'll answer no for that. And it's asking me if I want to save all EEPROM settings. And after all that work, I think the answer is yes. Okay, so the calibration values have been saved. The forward port is now calibrated and we can do some measurements, but one more step is required. we need to adjust the reflected channel trim pot. It's a simple operation. To do that, let me transmit a reasonable power level. Let's say 50 watts, as shown on the MB-1 meter. Okay, and it's gratifying to see that the two are all right. So right now we know we're transmitting according to MB1's reference point 51 watts. So let me show you what we have to do to adjust the reflected channel. Now, to do the reflected channel calibration, what I have to do is I have to swap these two connectors so that the power that I'm feeding through the coupler will effectively be read by the reflected channel port. And just don't forget, after the reflected channel calibration, to change these back. You can see that I have the adjustment stick in the trim pot for the reflected channel for coupler 4. Now let me go ahead and transmit my known power. What I have to do is place the meter in reflected channel calibration mode, and that's done with a long push of this button. You don't have to memorize these. The silkscreen legends do a pretty good job of letting you know what the functions do. And you can see there's a yellow light flashing, and that yellow light is basically an indication that you're in some special mode. You don't want to leave it in there. So now we'll simply go ahead and adjust the trim pot for 51 watts. Or as close as we can get. Alright, there's some long time constants in the filtering here, so sometimes you have to tweak the stick and give it a couple of seconds to settle down, and that looks pretty good. Any duration push on that button now brings us out of the reflected channel calibration mode. Our Radio Shack coupler is all set to go. So we're basically finished with the calibration. Now we can do some A/B measurements. Okay, we're ready for some A/B comparisons. Actually, I also have the LP100 and PowerMaster in tandem with the coupler that we calibrated, as well as with the Alpha 4510. And of course the SWRs are going to vary a little bit, but the forward power should be very, very close in terms of what the meter is actually seeing. So let's go ahead and pick a few measurements at random. Now remember, this meter was calibrated to this meter, and that's what we should see a fairly close match with. Let me go to the low end of the spectrum. Now, the PowerMaster cannot measure below 0.5 watts, and the LP100 starts at 50 milliwatts. So here, even at the very low power ranges, we're relatively close to the Alpha, 0.04 watts versus 0.045. The low power ranges are going to be the areas where you have the biggest discrepancies. Let me see if I can move up a little bit more. 0.05. 0.07 versus 0.67. 0.12. 0.48 versus 0.50. Okay, 1.43 versus 1.36. 5.08 versus 5.1. Alright, you can look at them, and I'll just go ahead and dial through, and we can observe some of the values. Okay, now I've got to power up the amplifier. Remember, we calibrated this up to 500 watts. And actually the meter will measure above 500 watts, but because we don't have any calibration points above 500 watts, it's going to use the calibration point for 500 watts to figure out the calibration curve for any power above that. So the point is that you really want a calibration point at the highest power you intend to use. But this $3 coupler is doing a pretty good job. But the point is, for my money, did a pretty good. Hey, 213 versus 213, 419 versus 420, and even above the 500 watt mark, it's not too shabby. And as you would expect, at least for most of the readings, this coupler is doing a better match with the alpha than let's see, 328 versus 330 versus 333. So not surprisingly, this guy matches up with this. Had we calibrated the MB-1 to line up with the LP100, its readings would be matching the LP100 readings. Had we calibrated the MB-1 to line up with the Power Master, its readings would be matching its readings. Now, if you see a few areas where maybe some improvement could be used, you can always go back with the edit function and edit those calibration points. Alright, so I think $3 coupler, we're able to do a pretty good job with the MB-1 calibration scheme. Now I just want to show you, let me zoom in. Let me zoom in on the coupler. We mentioned that this is a dual purpose switch. It allowed us to go into the setup mode. It also provides information. So let's go ahead and see what information we've actually stored for the coupler we've just calibrated. Okay, it's telling us that we calibrated at 21 points. It's a power coupler versus an RF current sensor or a generic meter application. Full scale power is 500 watts. The trim has to do with the coupler menu. You can go and read that, but we're not using trim here. This is a multi-page menu, so we continue to hit the display button to see additional information. The reference band we calibrated it at was 80 meters. And these are the actual ADC values that were recorded for each of the powers we calibrated at. So you can see the power points we calibrated at. This is actually the information stored in the internal calibration table. You can see we calibrated at 200, 300, and 400 watt points. And again, that's not always necessary, and that's our highest ADC that we were able to achieve with the pot at the full scale value. There are no band correction factors stored for this coupler. Test exit. Test gives you simply a continuity check, and if I go ahead and hit test, it's showing me what the ADC values are coming into the port. So really it's a simple continuity check to make sure the coupler is connected, and when you apply power you can see an ADC value that you think is reasonable. So it's a test function in that respect. Let me hit any menu button to continue. This display information is done. Had I shown you the information for coupler 1, it's very similar. The only difference is there we have some band correction factors for the 10 meter band and the 6 meter band. It turns out they're not really required for the MB-1 coupler, but had you done band correction, you'd have this additional information as well. Okay, and we can exit. Okay, so that's basically it, and for $3 we've got another coupler that we can use. Alright, thanks for joining us. I hope this was helpful. Coupler calibration is probably the most complicated operation you can do with MB-1, and certainly if you have any questions, shoot us an email at support@MeterBuilder.com. Okay, thanks a lot for joining us.